Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In this session, I want to go back to middle school and start working with you. I mean, I'm not going to explain to you how to add, subtract, multiply, or divide fractions because I think I already did that, and I hope you already covered this material. What I want to give you is something that may help you later. Like some other properties of fractions that I don't think you covered in class. So I know you covered the four operations. You learned how to find equivalent uh, uh, fractions if given one, or if given, or simplifying fractions. But there are few things that, I mean, you may know them, but at least I want to make sure you do. So these things would be about fractions, okay? So let me write, uh, in the beginning, I'm going to write two fractions that are equal using symbols like letters. And then I will show you what we do if we have equality, for example, of fractions with numbers, okay? So if I say, for example, A over B equals C over D, what can I make with that? I'm not talking about simplifying or even using, some people call it the cross or the butterfly, because when you say the product of these two numbers equal the product of those two numbers, so maybe that's the first property, is that AD equals BC. And we can write on the right, I will give you some examples. So if we have, for example, here 3 divided by 6, which is 1/2, equals, for example, 10 over 20, which is 1/2, right? All what that says is that if you multiply 3 by 20, is the same as multiplying 6 by 10. Of course, 3 times 2 is 6, and 0 next to that is 60, and 6 times 1 is 6, so 6 times 10 is also 60. Okay, so that's clear. Most, if not everybody, that at least most of you know that. Okay. So that's the first property. But there are some other properties. I will start with the easy ones that you may already know. For example, I can reverse them. Make the numerators denominator, I still get the same thing, right? So if I say, if this is true, then B over A equals D over C, right? Common sense. Like if I say, if I invert these, it would be 6 over 3 equals 20 over 10. Both of them are equal to. Okay, so that's also very clear, and I think you already know that. But you can also do or find other relationships. For example, if I divide on the top left by right and divide bottom left by right, I get the same thing. So I can rewrite this as A over C equals B over D. Notice that if you use the butterfly, you will get A times D equals B times C, but that's exactly what we said here. It's the same thing. Okay? Not only that, I can do it backwards. I can say, of course, I can, meaning I can switch those, or say C divided by A equals D divided by B. As long as you apply respectively what you do to one to the other, it's the same thing. So I have, once you tell me, oh, A over B equals C over D, I already know I can form 3 different equivalent fractions. I invert these, I make numerators denominators, or divide left by right or right by left. Okay, so far, so good. Nice. Let's go a little deeper. I can also say, and this may be as a surprise, I can say if I add a multiple of the denominator to the numerator, add or subtract. So plus or minus. And let's say I'm going to use a multiple of m. M is another number, okay? M times B over B is the same as C plus M D over D. Wait, what does that mean? Let's assume example. Let's take M equals, for example, 4. Okay? So here, remember we said 3 over 6. So that was A, that was B, that, that was C, and that was D. So if I use M equals 4, I say A, which is 3, plus M, which is 4, times B, which is 6, divided by B, which is 6, is the same as I do the same thing for C over D. So I say C plus 4 times D over D. It doesn't have to be 4. It can be negative 1/2. It can be 100. It doesn't matter, right? So 3 plus 24 over 6 equals 10 plus 80 over 20. 27 over 6 equals 90 over 20. What is 27 over 6? I know that 24 over 6 is 4. 27 is 3 more. So, and 3 over 6 is 1/2. We already said that. 3 over 6. So 4 and 1/2. If I divide, cancel the zeros, 9 divided by 2 is 4.5 also. Notice I could have said 3 minus that over 6 is 10 minus whatever, the same number over 20. And you will get two fractions that are negative. It doesn't matter, but it's the same. Do you know why is that? Because I can write this fraction, I can decompose it into two things, A over B plus M B over B, right? And I can say this is C over D plus M D over D. But B over B and D over D are 1. If I don't use a 0, of course. Okay, that's 1. So I get A over B plus M, which is 4. Notice A over B was 1/2. 1/2 plus 4, but C over D is also 1/2. 1/2 plus 4. So of course, if I add or subtract multiples of the denominator to or from the numerator, I don't change the equality or the equivalence of the fraction. One more thing, I can do the opposite. I can say A over B plus N times A, which it's as if I took them upside down, roughly, equals C over D plus N times C. Well, as we said, A is 3. So let's say example, N equals 5. Any number, you can write 10, you can write whatever. A is 3 over 6 plus 5 times 3 is the same as 10 over 20 plus 5 times 10. Well, the left-hand side is 3 over 21, right? 5 times 3 is 15 plus 6 is 21. The right-hand side is 10 and 5 times 10 is 50 plus 20 is 70. Yes, 1 over 7. You see 21 over 3 is 7. 70 over 10 is 7. Nice, right? So you can do many things. And then again, you can divide A by C would be this over that, or C over A is this over that. You can make a lot of relationships between these. And then you can multiply these two and you get the same as multiplying those two. So you apply the cross or the butterfly method to all of these. It's not a big deal, but I want you to see beyond just adding and subtracting fractions. You see that we can create relationships that are more compound than the ones we are having, and we know for sure without checking that what we are saying is correct. Notice that I can also, maybe the final thing I will do, of course, I can combine both. So I can say, for example, A plus MB over C plus ND equals, over, let's make it over B plus NA is the same as C plus MD over D plus NC. Let's see if that works. Let's pick, we don't have to use the 4 and the 5 as before. Let's say the M now is 10 and the N is 5. So A is 3 plus 10 times 6 over 6 plus 5 times 3. Is that the same as 10 plus 10 times 20 over 20 plus 5 times 10? Is that the same? Well, we don't know. The numerator here is 60 plus 3, 63, over 15 plus 6, 21. Notice this over that is 3. Okay? Equals 20 times 10 is 200 plus 10, 210. And this is 50 plus 20 is 70, also 3. 21 divided by 7 is 3. So you, as long as you keep whatever you do to the left-hand side is exactly the same as what you do to the right-hand side, then you get the same thing. And pretty much whatever I did here, I don't want to be too confusing to you, but I can do it. For example, I'm going to write this and that's it for now. Okay, I'm not going to make it much harder. I can say A plus M times C, which is on the other side, over B plus M times D. What would that give me? Let's use the M as one of the numbers we used before as 4, for example. So this would be 3 plus 4 times 10, and this is B, which is 6 plus 4 times 20. The numerator is 43, 40 plus 3. The denominator is 80 plus 6, which is 1/2, which is the same as A over B, is the same as C over D, is the same as that. So all of these relationships, you can go back over that. If you find it to be a little confusing near the end, you can slow down, stop it, and go check with, you make up some numbers different than those and check for yourself. And then you will see, as long as what you apply, to the numerator and the denominator on one side, you repeat it for the other side, your fractions would be equivalent. And that's it for today. I know it's a short one, even though it has a lot of material, but once you get these, you will have, a better understanding, I hope, for equivalency of fractions. And it may come back to help you, not to haunt you in the future. Thank you very much for your time. Hope to see you soon. Have a great day. Bye.